Alright, today I want to introduce something called direct variation, and then I'm going to introduce something called inverse variation. So this first table is an example of our direct variation, okay? And it's a pattern that I need you to recognize. So take a look at the table. I'll also add a little bit here because it's missing it. The top is x and the bottom is y. So 1 becomes 3, 2 becomes 6, 3 becomes 9, 5 becomes 15, and I've got a 9 here, and we need to fill in the blank. So we need to really figure out what the pattern is that's going along this table. And I hope you've figured it out by now. Every single one of these has been multiplied by 3. So we're going to continue that pattern one more time. So 9 times 3 is 27. So our answer in that question mark blank is 27. So the constant is that number that kept repeating. So we're multiplying by 3, we multiply by 3, we multiply by 3, so our constant is 3. Now let's go and see what the graph of this would look like. So if I graph my first one, 1, 3, graph my second one, 2, 6, my next one's off the graph, my next one's off the graph, so I'm actually out of things I can graph, but I want to write the equation of the line. So what I need to do is figure out a way that I can get this back to my y-axis so I can figure out my y-intercept. So go back to this in your slope. It's up 3 over 1 to this point, so we must be going down 3 over 1 to this point. So it's going to go right through the origin. And that's a really big thing in direct variation because every direct variation starts at the origin and keeps going. Now notice why we call it the constant. It's constantly going up by 3 every 1 that we go over. So that's the constant there. So let's go and fill in our notes. So we've got a table here, and I need you to figure out the pattern. So the constant of variation, that's what we call it. Negative 6 becomes negative 3, 2 becomes 1, 4 becomes 2. So each time they are halving. So they're being divided by 2, but we can't say divide by 2. We have to say they've been halved. So 1/2 will do division for you. And how do you know? You can see the pattern right there. So if I have 5, then I half it and I get 2.5. If I already have 6, how do I get back to the x? Well, I've got to go the opposite way. So if it's divide by 2 this way, it must be multiplied by 2 this way. So it must have been a 12 right there. Now, writing the equation of the line, let's graph it so we can see it. We've got 2, 1, oops, sorry, forgot negative 6, negative 3. We've got 2, 1. We've got 4, 2. I'm going to skip over the decimal one for now, and I can't fit up 6. So remember, let's do the slope backwards. So up 1 over 2, down 1, backwards 2, down 1, backwards 2, down 1, backwards 2. That lines up perfectly. So the equation of the line is going to be y equals, our slope was up 1 over 2, so 1/2. Hey, take a look at that. Our constant is the slope. And then x. So when we were writing this, I don't know if you noticed what we were doing. We were using slope-intercept form. So we found the slope, the m, have our x, and then I didn't write anything with the plus b because it was plus a 0, and we're just simplifying it by not writing it. It doesn't add anything to it. So here's what's most important for you about direct variation. The tables, the same thing. Every x is being multiplied by the same number. So every x is being multiplied by the same number. What do the lines look like? They're diagonal lines that go straight through the origin. So the origin is 0, 0. That's a very important part there. What is the constant of variation? Well, we found it as that pattern, but there's actually a formula that can give it to you. The variable here that stands for constant is k. That comes from the German word for constant, which starts with a k. And the pattern that you have is you take any y and divide by the x, and you'll actually have this value right here. So you'll figure out what to multiply by if you divide. So we've got any y divided by any x will give you that constant value we found. And what do our equations look like? Well, they've got a form to them. It's like slope-intercept form here, except we only take this part. So we call it y equals kx. So k and m are the same thing, just this is just more specific to direct variation. So I've got 3 pictures for you right here, and you've got to decide which one is direct variation, and you've got to explain your reasoning. I've got a diagonal, I've got a vertical line, and I've got a diagonal that goes through the origin. And the answer is that third one, because it goes through the origin. So that's your reason right there. That diagonal is going through the origin. Let's try another problem. If y varies directly with x, and y equals 6 when x equals 3, what's the constant of variation? So let's make a table just like we were looking at before. So we know it's varying directly. That tells us we can follow this pattern. I've got a 3 for my x, a 6 for my y. I notice that just got twice as big. So my constant is multiply by 2. Let's write the equation of the line. Remember, that's y equals kx. So all we need is that constant we were talking about, so 2x. Now I hope this equation makes sense to you. It says every x gets multiplied by 2. That's what it's saying. So 2 times x, that means every x you plug in here will get multiplied by 2 to get your y value. So let's use it with our next one here. So x is 10. So plug it into the right spot. So we are doubling it from the top to the bottom. So that should become 20, twice as big. For my third question, it gives you the y value is 9. So this time we're going to stick that in the denominator, or in the bottom, sorry, not the denominator, bottom of the table. So if we were multiplying it by 2 to go down, to go up, we need to do the opposite, so divide by 2. So half of 9 is 4.5. All right, let's try out another problem. If D varies directly with C, now hold up, they're changing our variable, so let's go back. Let's follow a pattern. Y varies directly with X, so Y comes first, then X. So D must be our Y, and then our X must be C. So when I go to make this table, I'm thinking XY, but it's really going to be CD. So if D varies directly with C, and D is negative 5, when C is 15, make a table with the given information. Hey, we did that. Now add C equals 9 to your table. So C should be in the top. Predict its D value. Well, let's see what's happening here. 15 became negative 5, so we must have divided by negative 3. So let's divide this one by negative 3, and that also becomes negative 3. So 9 divided by negative 3 is negative 3. So what's the constant variation? We said we were dividing by negative 3. So you can't just say divide by negative 3. That's not going to work. So put that in its fraction form, negative 1/3. Now let's write the equation of the line. Y equals, put in your constant, and then your x. Now I also want to show you something that happens. Like the way we wrote it is perfectly fine, but the way we said it is almost a little bit better. So instead of saying negative 1/3 of x, we could also say take our x and divide by negative 3. So that's the pattern. So both of those are okay. I would say multiple choice would tend to combine down that 1/3 into one fraction instead. Alright, so that's it for direct variation. Now let's go and look at some inverse variation. So let's just start with the table again and see if you can figure out the pattern. So this is a different pattern, so it can't be the same thing as direct variation, or we'd call it direct variation. Inverse variation does something different. So I've got a 2, it becomes a 6. I've got a 3, it becomes a 4. But then a 4 goes down to 3, and a 6 goes down to 2. And we want to figure out what 12 becomes. So what's my y value that goes with it? And the trick here is it's nothing that's happening to it. It's more of what they multiply to. So 2 times 6 is 12, 3 times 4 is 12, 4 times 3 is 12, 6 times 2 is 12. So 12 times what is 12, and that is just another 1. So 12 times 1 is 12 itself. So what's in the blank? A 1. What's the constant of variation? That number that kept coming up constantly is 12. And predict what the graph would look like. So let's take a look at it right here. Remember, the top is x, the bottom is y. So I've got a 2 and a 6. I've got a 3 and a 4. I've got a 4 and a 3. I've got a 6 and a 2. And what's happening here, it's curving around, and it's actually going to curve really close to the axes here, but not go over them. All right. So let's try out some practice. Sorry, that's the wrong page. Let me go to the right thing. Let's finish up these notes right here. So it says finish the table below and sketch a quick graph. So we want to know that it's that curve. You don't really have to be as specific as you were before. So what is the constant of variation? Let's try it out. This is inverse, so think of a pattern for inverse. Negative 2 times 3 is negative 6. We don't know this one. Let's try 4 and 1.5. So 4 times negative 1.5. Oh, that's negative 6 as well. And one more check. Negative 3 times 2 is also negative 6. So our constant must be negative 6. Now we've got to write the equation of the curve. Though we should probably finish the table first. So we got to figure this out. So negative 1 times what would make negative 6? Negative 1 times 6. And the equation of the curve looks exactly like this. So if you didn't know what that value was, what you would do is divide your negative 6 by your x value to figure out the missing one. So our equations of our inverse look a little bit different. So let's talk about that right away. Oops, a little too far there. So what do the tables look like? X times y multiplies to the same number each time. And we call that the constant. Ooh, sorry about that. A little crazy there. What do the lines look like? These are curves. And really we usually focus on one quadrant at a time, so they don't pass the axis. So our specific table here, see how it's negative, positive? It would be a curve up in this quadrant right here. It does have a partner curve that we're not going to talk about right now. What's the constant of variation? All you have to do is take your x and multiply it by your y, and that will give you your constant. Remember, k stands for constant of variation. And what do the equations look like? This is where we're heading. So you've got to know a specific form here. So it's y is equal to k divided by x. So again, remember that k is your constant of variation. Because you're going to know that number already. And what you're going to need to do is plug in x's to figure out y. So if you already know something multiplies, like say you know something multiplies to 30 already, and you know your x value is, let's say 10, and you want to know what multiplies to 30, you would divide that by 10 to figure out what that other missing value was. So that's what this is doing over here. It's saying take the number you know, that constant that's always true, divide by the number you know to figure out the number you don't know. So we've got a little bit of practice here. Let's try it out. It says find the constant of variation, then write the equation using it. So it varies inversely. So we're going to make a little table here to help us out. Just look at it. We've got a y is 5 and x is 1, and those multiply together. 1 times 5 is 5. So our constant is 5, and our equation we need to write is the one with the division. So 5 divided by x. Now we've got another one here, but they've changed up our variables. So follow the pattern. Y comes first and then x. So when I draw this little table, I know that my x is really p and my y is really n. So I know this is negative 2 and 7. Multiply those together, you get negative 14. So our k is negative 14. So we need to write y equals negative 14 over x, but we're going to change that up and plug in the right variables. So n is equal to negative 14 over p. So y is my n, p is my x. Got a third one here. Y varies inversely with x, so we're back to our normal. X is 2, y is 12.5. It wants to know a new y value when x is 10. So let's figure out, because it varies inversely, it needs to multiply to the same number. 2 times 12.5 is 25. So we've got to figure out 10 times what makes 25. So if you're really good at it, you know it in your head. If not, let's go to our calculator. Let's put that formula into action. We know what the constant is, 25. And let's divide by the x value we know to find the y value we want to know. So 2.5. So 10 times 2.5 is 25 as well. All right, just a quick summary. Direct variation versus inverse variation. Direct variation is like this. You've got 1, it becomes 3. You've got 2, it becomes 6. You've got 3, it becomes 9. Inverse variations like this. You've got 4, 6 goes with it. You've got 3, 8 goes with it. You've got 12, 2 goes with it. Direct variation, the same number multiplies from one to the other. So this would be y equals 3x. This one, they multiply to the same number, 24 in this case. So the equation would be y equals 24 divided by your x. All right, that's it.